Welcome to The Explainer. Today, we're going to talk about something every single programmer runs into, the dreaded program crash. You know, that moment of pure frustration. But what if I told you we could turn that chaos into one of your most powerful tools? Yeah, we're going to do exactly that. So let's start with a feeling I know you've had, especially if you're learning Java. You write some code, you feel good about it, you hit that run button, and bam, everything just stops. And you're staring at this wall of angry red text. What in the world just happened? All right, so here's a plan. First, we'll look at why code breaks. Then, we'll check out Java's super smart solution for it. I'll show you the toolkit you get to handle these situations, and then we'll see how to go from a crash to being in complete control. And finally, we'll look at the exception family tree. Let's get into it. Okay, section 1. Let's break down the anatomy of a crash. We gotta get to the bottom of why our programs just stop. So let's look at a super simple piece of code that is absolutely guaranteed to fail. So check this out. It looks totally innocent, doesn't it? We've got an integer d that's set to 0. Then we try to do some simple math, 42 divided by d. Uh-oh, remember that one rule from grade school math, the big one? You can't divide by 0. And that's exactly what we're telling the computer to do right here. And when you run that code, the Java runtime system just hits the emergency brake. It stops everything dead in its tracks and spits out this message. Now, this thing is called a stack trace. And I know it looks scary, but it's actually your best friend. Seriously, it's like a set of clues. It's telling you exactly what went wrong, an arithmetic exception, and even where it happened, line 4 of our file. Pretty cool, right? Now for the really cool part. Java doesn't just see this as a crash and throw its hands up. No, it sees it as an exceptional condition. And it has this really elegant, really smart way of dealing with it. So instead of just quitting the second that error happens, Java does something amazing. It creates a special object, an exception object. You can think of it like a little messenger carrying a detailed report. Hey, something went wrong. Here's what it was, and here's where it happened. And then Java throws this object, kind of like throwing a flag in a football game. It's a signal that your code has a chance to, well, catch. And this is the big idea right here. We're not just letting our programs die anymore. We're bringing error management right into our code. We're treating errors like any other object, something we can actually control and manage. It's a total game changer. Okay, so how do we actually do this? How do we catch that flag? Well, Java gives us this awesome toolkit. It's made up of 5 special keywords that give you total control when things start to go sideways. All right, these keywords are try, catch, finally, throw, and throws. Now, they all have their own jobs, but the real heart of exception handling, the dynamic duo, is try and catch. And that's what we're really going to dig into today. Okay, let's get our hands dirty. We're going to go back to that piece of code that kept crashing on us. But this time, we're going to wrap it up in a try and catch block and see how we can take back control. And look at this. It's like a night and day. On the left, that's the old way. Crash and burn. The program just dies. But on the right, we catch the error. We print out a nice, clean message that says division by 0, and guess what? The program keeps on going. This is what we want. So how does this work step by step? First, you take the code that you think might be a little risky, the code that could throw an exception, and you put it inside a try block. It's basically you telling Java, hey, keep an eye on this bit of code for me, will ya? Okay, so the program starts running the code inside try. Then it hits that line, the division by 0. The Java runtime system sees this, and immediately, instantly, it creates that arithmetic exception object and throws it. Now, this part is super important. The second that exception gets thrown, your program's execution jumps right out of the try block. It doesn't finish the rest of the code in there. It just abandons ship and looks for a catch block that knows how to handle an arithmetic exception. So, control lands in our catch block. We do whatever we need to do. Here, we're just printing a message. And then, here's the magic. Once the catch block is done, the program doesn't crash. It just calmly moves on to the next line of code right after the try-catch part. We've literally prevented the crash from happening. And check this out, it gets even better. The catch block actually catches the exception object itself. See that little E? That's our error report. We can print it out and get all the juicy details from the original error message. This is so useful for logging what's going on or for debugging. Way better than just a crash, right? All right, so we get it. We can catch an arithmetic exception. But what about other errors?
Java has a whole bunch of different exception types. It's like a big family tree. So which ones are our problem? Which ones should we be looking out for?
So at the very top of this family tree, you have a class called throwable. Think of it as the ancestor of every possible thing that can go wrong. And throwable has two main kids, error and exception. And this is where things get really interesting.
Here's what you really need to know. Your job as a developer is to focus on the exception side of the family. These are the things your code might cause, like our division by zero, or maybe trying to open a file that isn't there. The other side, the error side, those are for huge, catastrophic system-level problems, like the whole program running out of memory. You're not really supposed to try and fix those, so stick to catching exceptions.
So look, by really getting a handle on try and catch, you've completely changed the game. You're not just someone who writes code anymore. You're building applications that can handle problems, that are robust, that don't just fall over when something unexpected happens. You've gone from being a victim of errors to the one in control. So, now that you have this power, what kind of unbreakable code are you going to write?